Today we're going to be talking about Pythagorean theorem and having an introduction to that theorem that we'll talk about. First, go ahead and try these 3 Ignite problems at the top. So you're simplifying those radicals. Continue playing the video to check your work. All right, so for number 1, you should get 5 root 7. Number 2 is 2 root 5. And for number 3, we want to simplify that 2 squared first, which is 4, and then the square root of 4 is 2. So we talked a little bit yesterday about the square root being the inverse function to squaring a number, so that's why we end up with just 2 at the end there. So today we're going to be talking about the Pythagorean theorem. One thing that's really important to note is that Pythagorean theorem works for right triangles only. Okay, so here we have a triangle, here is my right angle, and now we're going to label the parts of the triangle. Some of these you may have heard before, some of them maybe not. So hypotenuse is going to be the side length that is directly across from that 90-degree angle. So the hypotenuse does not form the 90-degree angle. Okay, so this is my hypotenuse. And then the letter we use to represent the hypotenuse is C. Okay, now the other two sides, and we already have our right angle labeled, so that's just right in the corner there. The other two sides of our triangle are going to be the legs, and those are the two sides that form the right angle. So here's a leg, and here's a leg, okay? And then we just label those as A and B. It doesn't matter which one is A and which one is B, as long as the legs are A and B. Okay, so what is the Pythagorean theorem? We have these letters over here, A, B, and C, representing the different sides of my triangle. So the Pythagorean theorem is A squared plus B squared equals C squared. So this means that the two legs squared added together equal that hypotenuse value. So for example 1, we're going to use the Pythagorean theorem to find the missing side lengths of the following right triangles. So here's my A, B, and C. That hypotenuse is always across from the right angle. So we have our A value squared plus square root of 5. We want to square that whole thing, so we're going to use parentheses, equals C squared. So 2 squared gives me 4. The square root of 5 squared, those are inverse operations, so they cancel each other out, and we just have 5 equals C squared. 4 plus 5 is 9. And then we square root both sides. Square root of 9 is 3, so C is 3. When we get to this point, we still have C squared, and I want just C, so that's why we have to square root both sides. And then we're just simplifying the radical. Square root of 9 is 3. So that's all we have to do there. Over here, we have our hypotenuse across from those two side lengths, and we have A and B. So we have 10 squared plus 5 squared equals C squared. And you could use X if you wanted instead of C. It doesn't matter as long as that is the side length that's by itself. So 10 squared is 100. 5 squared is 25, and then that equals C squared. So we have 100 plus 25 gives me 125 equals C squared. So again, we need to get C by itself, so we're going to square root both sides. The square root cancels over here, and we just have C. But now we need to reduce this radical here, okay, because I can't take the square root of 125. But I can divide 125 by 5 to give me 25. And then I can split that up into 2 5s as well. So I'm looking for pairs of numbers. I have a pair of 5s and then 1 by itself. So I have 1 5 outside the radical, 1 5 stays inside. So that C value is 5 root 5. We can go ahead and move on to the next page. We have 2 more to talk about here. So for C, again, we're looking for that hypotenuse side. I have one of the legs and the other legs. So I have 9 squared plus 5 root 7 squared. And that equals my hypotenuse squared. So 9 squared is 81. 5 root 7 squared is 175. And that equals c squared. 81 plus 175 is 256, equals c squared. So to get c by itself, we're going to square root. And we can check to see if this will simplify nicely on our calculator before we try to reduce. And it does. The square root of 256 is actually 16. So 16 equals c. And then last one, D, looking for our hypotenuse, we have a and b. So we have 6 squared plus 6 squared equals c squared. 6 squared plus 6 squared, both of those are 36. So we have 36 plus 36. Add those together and we get 72. And square root both sides. This one is not nice, so we will have to simplify this down. So we have 2 and 36. Oops. 2 and 18, 2 and 9, and 3 and 3. So we have a pair of 3s, so I can bring out a 3, pair of 2s, and then 1, 2 left over. So I just need to multiply those together. I get 6 root 2 equals c squared. Or not c squared, just c. Sorry, there we go. So my answer for c is 6 root 2. Go ahead and try the 2 you try nows on your own and then play the video to check your work. So for number 1, we should just get the square root of 113. I can't reduce that, so I just leave my answer as it is. And for number 2, when we simplify that radical, we should get 2 root 61. When you're done, go ahead and move on with the homework and let me know if you have any questions.